Welcome to Math 1324. We are looking here at Section 5.1. So here in question 1, they want to know, is that point 227 on this line y equals 3x plus 18? Well, let's find out. So let's see, I've got y equals 3x plus 18. And I want to know, is this point 227 actually on that line or not? And so looking at the point, I see x equals 2 and I see y is 27. So substituting in, the question is 27, is that equal to 3 times 2 plus 18? Let's see, 27 equals 3 times 2 is 6, 6 plus 18. So I've got 27 equal to 24. Well, no, that's not true. So no, this point does not live on our line. So let's come over here, we'll click no and check, and it's happy. Question 2, we have an inequality and they want to know, does that point satisfy the inequality, yes or no? So let's see here. I've got the inequality is y less than or equal to 3x minus 8. And I want to know, does this point satisfy it, yes or no? Well, again, let's find out. So x is 6 and y is 5. Let's see, 5, is that less than or equal to 3 times 6 minus 8? So is 5 less than or equal to 18 minus 8? Well, 18 minus 8 is 10. Is 5 smaller than 10? Yes, that is true. All right, so we come back over here. Does it work? And the answer is yes. And we check that. All right, now in this next question, they actually want me to graph the inequality on the graph here. And so let's click this and let's see, what do I see there? Well, I see a pointer, a line tool that needs 2 points, a V, we don't need that, a U, don't need any U's or circles. We've got a painting thing, we'll see how to use that in a moment. We've got a solid line or a dotted line. Notice the inequality has an equal. So when we graph the line, it's going to be a solid line. Okay, so let's see. I need to know, what does this thing look like? So let's see. My line looks like y greater than or equal to x plus 3. Okay, so I don't need the inequality right now. I just need to know, what does this line look like? Well, I can look at it and say that the slope is 1. The y-intercept is 3. Okay, so I could use that fact to plot the graph, or I could set x to 0. And if x is 0, I get y is 3. And if I set y to 0, I have 0 equals x plus 3. or minus 3 is equal to x? All right, so I've got 2 points. I've got 0, 3, and I've got minus 3, 0. So I can come back over here, let's see, and put that. We've got minus 3, 0, and we had 0, 3. Okay, see how I made my line? Now, let's just make sure we got the right points. 0, 3, minus 3, and 0. Yep, that's good. Now, if we needed a dotted line, you would just simply click that, and it makes it dotted. All right, but it's solid. So got that. And next, now that I've done that, I need to see, since it's an inequality, what's going to work. And on these problems, either under the line works or above the line works. All I need to do is pick one point to test and see if it works or not. You just need to pick one point not on the line. So I'm going to pick 0, 0. So here's the question. Does 0, 0 work or not? Go back to my inequality here. Is it true 0 is greater than or equal to 0 plus 3? Is 0 bigger than 3? That's a no. That means every point on that side will fail. So nothing over here works, and so when I grab my shading tool, I shade in the stuff on the top. And so we'll save it and check it, and it's happy. Okay, in our next case, let's see, they want x less than or equal to minus 1. So let's see, x less than or equal to minus 1. So I'm interested in the line x equals minus 1. But if you remember, we had a few special kinds of lines. If my line was completely flat, those looked like y equals a number. And if we had a vertical line, those lines looked like x equals a number. So here I have x equals minus 1. Okay, so that's simply going to be a vertical line crossing here at minus 1. All right, so let's see if we can graph that. Come back over here, get my graph. Line tool, minus 1, minus 1. There it is. And so now I just need to pick a point and see, well, which side would I shade? The right or the left? Well, let's see. Let me pick my 0, 0 point. All right, let's try that out. Is it true 0 is less than or equal to minus 1? That's a no. So that means everything on this side fails, and I'm going to shade everything on the left. And let's see if it's happy, and it is. All right, question 5. I've got 2x plus 3y less than or equal to 6. All right, let's see. 2x plus 3y less than or equal to 6. All right, but all we really care at first is, what does the line look like? Well, the easiest way to do this is set x to 0 and find y. So 3y is equal to 6. Divide by 3, and I get y is 2. So I've got the point 0, 2. And then I switch. Y equals 0. Y is 0. I get 2x is 6. And I get x is 3. So my other point is 3, 0. So I simply am looking for the x and y intercepts. So let's come back. 0, 2, 0, 2, and 3, 0. There we go. So there's my line. One side will work, the other one will not. I need to figure out, well, which way do I do it? So I'm noticing right there 0, 0 is not on the line, so let's try it out. So let's see, 0, 0, 0, 0. 2 times 0 plus 3 times 0, is that less than or equal to 6? Well, that's all just 0. So is 0 smaller than 6? Well, that answer is yes. Okay, so let's see. That does work. So come back to my graph here, and I'm going to shade that and save it. And then we'll see, is the problem happy? And it is. Question 6. All right, let's see. I've got 7x greater than or equal to minus 3y. All right, so 7x greater than or equal to minus 3y. All right, but again, I don't care about the inequality right now. I just want to know, what does this line look like? Well, if I try my normal trick of setting x equals 0, if x is 0, I get 0 equals minus 3y. And that just says that y is 0. And so this line is going through the origin. So there is only one intercept. But I would like to find another point. How will I do that? Well, one way is to take this problem and divide by 3. So 7 over minus 3x equals y. And if you remember, we had rise over run. So the rise is equal to 7, and the run is equal to minus 3. So this line is going down. Let's see if we can do that. All right, so we're going down. Come over here and make my graph. I know one point is here at the origin. I know I need to go 1, 2, 3, and now down 1, 2, 3, 4, 5, 6, 7. All right, that looks good. Now I need to pick one test point and see if it works or not. Well, the problem is I can't pick 0, 0. It's on the line. But it doesn't matter. You can pick anything else that you like that's not on the line. How about 2, 0? Let's try it out. So trying out 2, 0. Let's see. 2 and 0. So 7 times 0, is that greater than or equal to minus 3 times 2? So is 0 bigger than minus 6? Oh, that's a yes. That means that the point 2, 0 does work, and that's over here. So I'm going to shade that side, save it, and let's see if it's happy. And it is. All right, so looking here at question 7, they are giving me a graph. So let's make it bigger. So looking at this graph, I'm looking at the graph and they want me to figure out, well, which of these things over here, A, B, C, or D, actually match that particular picture. Notice they're all the same. The only difference would be the inequalities. Now, looking at this, I can tell you it can't be A and it can't be C because I would have a dotted line. In these, I have a solid line. Therefore, it's got to be one of the inequalities with an equal. So it's either got to be B or D. So let's see. I have 7x plus 2y. And let's see, let's take the less than or equal to minus 14. I'm looking here at B. Let's see, 0, 0 is not on the line. So let's see, 0, 0. So is it true 7 times 0 plus 2 times 0 is less than or equal to minus 14? Is 0 smaller than minus 14? Well, that's a no. And since it's a no, I would not shade that side, but I would shade the other side. So that tells me, looking at this, that it must be B because 0, 0 doesn't work. I've got a solid line and it must be that inequality. And it's happy. Question 8. Okay, question 8 says, I've got 12x plus 3y less than or equal to 1200, x and y greater than or equal to 0. Okay, so let's see. What do we have? So looking at this, the first thing I notice is this business about x greater than or equal to 0 and y greater than or equal to 0. Those two items mean that when we go to graph this thing, I'm going to have to graph x equals 0. I'm going to have to graph y equals 0. And my answer must live here in quadrant 1. So let me come back over here for a moment and make those lines. So vertical, vertical, and then flat and flat. Okay, so I've got at least those two. Now my other one is 12x plus 30y is equal to 1200. I went ahead and set it equal because all I really care about is the line. All right, so I said x equals 0. Well, that would give me 30y is 1200. And so I'm going to divide by 30. So cancel one of those. And I see my answer is 40. Okay, so x is 0 and y is 40. Well, what if y is 0? If y is 0, let's see, that gives me 12x is 1200. And if I divide by 12, I get 100. All right, so I need 100 for X and 0 for Y. And 040. All right, 040. Got that. And 100 and 0. All right, so far, notice I've got all my lines. And whatever happens, it must live here in quadrant 1. So it's either going to be the stuff above or the stuff in this little triangle. So let's see, which one is it? Well, let me try 0, 0. 0, 0. So is it true 12 times 0 plus 30 times 0? Is that less than or equal to 1200? Well, all of this stuff is 0, and is 0 less than 1200? Well, that's a yes. So over here, I need to shade in this tiny little triangle. So let me do that and save it. It's just that one little piece there. So let's see if it's happy. And it is. Question 9. Okay, question 9 is similar. I've got a line. I've got my x and y greater than or equal to 0. So I know what happens with that stuff. So let me get my vertical line here and my flat line over here. So I got all that, and I need to get the rest of this stuff. So let's see. I've got minus 10x plus 25y greater than or equal to 1500. All right, well, let's see. I need to know, what does the line look like? First off, plus 25y equals 1500. All right, so if I said x to 0, I get 25y equals 1500. And if I divide by 25, I'm going to get something. Let me get my calculator here, and we'll see what that happens to be. So 1500 divided by 25, I get 60. All right, so this is a 60. All right, so 0, 60 is 1 point. Now if I let y be 0, so y is 0, I get minus 10x is 1500. And if I divide by minus 10, let's see, that cancels, and I get a minus 150. All right, so I get the point minus 150 and 0. All right, let's see if I can do all this. Minus 150 and 0, yes. And we had, I think, 60 was my other point. Yeah, 0, 60. All right, so we're good. And so the question is, well, where do we shade? Remember, it's got to live in quadrant 1. So it either is this stuff in here or that stuff way up in that top little corner. Let me try 0, 0, because that's not on the line, and we'll see. So if I try 0, 0, 0, 0, I'd have minus 10 times 0 plus 25 times 0. And is that bigger than 1500? Well, that's all just 0. And is 0 bigger than 1500? And that answer is no. So 0, 0 is not going to work. So what works is the other side. So let's see, I need to shade that little piece there. Okay, let's see if it's happy. And it is. So hopefully you are happy as well. Let's see, question 10. All right, question 10, I've got, again, I'm here in quadrant 1. So let me get my lines going. Because if I don't put these lines here, when you paint it with the paint can, it all leaks out. Let's see, I've got 21x minus 30y less than 0. Oh, it's a less than 2 here, so we're going to have a dotted line. Well, let's see. So what does this line look like? 21x minus 30y equals to 0. Well, if x is 0, I get minus 30y equals 0, but that just says y equals 0. So I get 1 point, which is 0, 0. But I need more than that. So let's see, how will we do that? Well, I could move the 30 over and I would get 21x equals 30y. And if I divide by 30, I could try our rise over run business again and see if that works. Let's see, 21 over 30. Oh, that's not going to work so well too because, well, I can't go that far. Huh. So what in the world are we going to do? Well, let's see. Oh, 21 over 30, I think I can reduce that. Right? Because I could take a 3 into the top and I'd get a 7. And I could take a 3 into the bottom and I could get a 10. Oh, a run of 10, a rise of 7. I think that'll work. Let's see. All right, so 0, 0, a run of 7. Was it 7? Let's see. 10, sorry, a 10 on the bottom. So a 10 on the bottom, got it. And now up 7. I think that's good. So that looks good. It is going through the origin. It is over 10 and up 7. But wait, it's got to be a dotted line. I can't pick 0, 0 because that's on the line. I need to pick something not on the line, so I'm going to pick 2, 0. So let's see, 2, 0. 2, 0. So 21 times 2. I'm going all the way back up to there. So 21 times 2 minus 30 times 0. Is that less than 0? Well, 21 times 2 would be 42. And is 42 less than 0? No way. So 2, 0 fails. So 2, 0 fails. That must mean all of that stuff works. And let's see. And yes, it is happy as well. And so that concludes section 5.1.